In this video, we will be discussing control flow in R, specifically compound statements and conditional statements. Compound statement or block is one or more statements that are grouped together using curly braces. So if we were to write a very simple statement like 5 squared, we see that the code block outputs 25 as a result. And if we were to add another statement like 1 plus 1, we see that the output now includes both 25 and 2. Each line in this code block is a statement. Now, if we repeat these statements and wrap them with curly braces, we get a compound statement. But notice that when we run this code block, the output is different. Only the result of the last statement in the compound statement was actually output here. This is because the value of a compound statement is taken from the last statement within the compound statement. And in this case, the value 2 is coming from the last statement, 1 plus 1. Okay, so we got this definition of compound statements sort of out of the way, and we're going to be coming back and using that throughout the notebook. But right now I want to talk about control flow and some specific statements that affect the flow of code. Control flow refers to the order in which statements are evaluated. An example of this would be a conditional statement that evaluates a statement or block only if some condition is met or is true. Or perhaps, let's say, a looping statement that executes a statement or block 0 more times, again, depending on whether or not a specific condition is met. There are other examples like functions, but in this notebook, we're going to focus on the if-else statement, the switch function, and a few looping statements, namely for, while, and repeat. To get started, the if-else statement evaluates one of two possible statements depending on the evaluation of a condition. This takes the form of the if keyword, followed by a conditional expression in parentheses, followed by a single statement or compound statement that is to be executed only if the conditional expression evaluates as true. After this, we may optionally include the else statement, followed again by either a single statement or a compound statement that is to be executed only if the conditional expression evaluated to false. As an example, if we had an input x, which is some integer, we could actually use an if-else statement to print text to the console stating whether or not the value of x was positive or otherwise. So to do this, let's create first a variable x, and we'll give it the value 5. Now, in reality, we may get this value from user input or maybe a file or something, but just to keep this simple, we're going to define x to be 5. And then we're going to write the keyword if, followed by a conditional expression in parentheses. And in this case, we want to know if x is positive, which really means is x greater than 0. So I'm going to write x greater than 0. And if this evaluates to true, I want to output x is positive. So I'm going to use the cat function and pass the string x is positive here. Now, we're only including a single statement as part of the body of the if, and so the curly braces are really optional, but I'm going to leave them here for completeness. If we also wanted to output something when x is not positive, when it's negative or 0, we can't just add another cat statement after our current if statement, because it would always output whether x was positive or not. So we're going to need to use the else statement to allow us to have code that only runs when x is not greater than 0. So to see this, I'm going to write else, and then in curly braces, again, I'm going to use the cat function and pass the string x is 0 or negative. Also note that the else statement should appear in the same line as the closing curly brace from the if compound statement. If it does not, say we were to add a new line here and run this block again, you see that we actually get an error. So do make sure that these occur on the same line. Also, if we make x negative, we'll see that we get the output x is 0 or negative. Now, the if-else statements can also be nested. So if we also wanted to detect if x is 0, not just 0 or negative, we can modify this example by adding another if statement. Here we'll specifically check if x is equal to 0, and then the body of this nested if statement will output x is 0. And now we can differentiate between positive, negative, and 0. And when we run this code block, we'll see here that x is in fact negative and not just 0 or negative. Now, one last thing I want to point out about if-else statements is that they actually return a value, just like all the other statements we've seen. And we can output this value using computations or simply assign it to a variable. For instance, maybe we would like to conditionally set the variable y here to a positive value or negative value, depending on whether or not x itself was positive or negative. So for the right-hand side here, if I write if x is greater than 0, I'll return the value 12. Else, return the value negative 12. And then we're going to simply output y. And we see that because the value of x is negative 5, y receives the value negative 12. In many languages, there is a keyword similar in functionality to the if-else statement, but is meant to more clearly and easily handle multiple cases, and that is the switch statement. R doesn't actually include a switch statement as part of the built-in set of keywords, but instead it does include a function that provides similar functionality. So in general, the switch statement can be implemented using nested if-else statements, just as we saw in the above example where we checked if x was positive, negative, or 0. However, the switch function provided by R is somewhat more specific. The arguments to this function are first, an expression that should evaluate to a numeric value or a character string. If it doesn't evaluate to one of those two, then it's coerced to be a numeric value. Following this first argument, the switch function takes a list of alternatives or cases. If the first argument is numeric, then effectively it is treated like an index. It's used to select from this list of alternatives or cases, meaning that the result of the first argument decides which of the subsequent arguments are actually evaluated, and the value returned by the switch function is a result of that selected argument. So that was a little bit to take in. Let's just call the switch function, and we're going to pass it 4 arguments. The first one is going to be x. X is going to be a numeric value. So we start off with x is 2, and I'm going to write switch in the first argument x. The last 3 arguments that I want to pass here are going to be different expressions from which only one is going to be evaluated. So the switch function is going to take advantage of R's lazy evaluation, meaning that because x has the value 2, it's going to evaluate the mean of the sequence from 1 to 10, and it will not evaluate the other 2 expressions, namely the 10 plus 2 or the print x that were passed. And so if we run the code block, we see that we get an output of 5.5, which is the mean of the sequence 1 through 10. If we were to change the value of x to 1, you'll see that now it outputs 12, because it selected the expression 10 plus 2. And if we change it, say, to 3, you'll see that it prints out the value 3 using the print function that we see at the end of the argument list in the switch statement. Now, when we started describing the switch statement, I said that the first argument, x in this example, should evaluate to a numeric value, either directly or via coercion, or it should evaluate to a character vector. If it is a character vector of length 1, then that string will be matched against the names of all the remaining arguments passed to the switch function. Now, in this example, we didn't provide any names for these arguments, but we may do so. So let's do another example where I use the switch function, and this time we'll switch on the variable y, which we'll define momentarily. And for the alternatives list, I'm going to label each of the alternatives as follows. I'm going to say dog equals a string containing the word poodle. The next element will be bird containing the string parrot. And then for our variable y, we'll assign a string containing the word dog. And so when we run this, instead of using the numeric index, the switch function used the string dog to identify which of the alternatives to return using its label. And so in this case, it matched dog exactly and returned poodle. I should point out that if it does not match exactly, then null will be returned. So for instance, if I made a capital D here for dog, you see that nothing is actually output here. And that's because we're receiving a null value from switch, and Jupyter Notebook is hiding that from us. In the console, you would actually see it type the word null. And in cases like this one, we can actually provide a default value for the switch function by including a single unnamed option in the argument list. So when the value of y doesn't match one of our labels exactly, the default value will be returned in place of null. So if we repeat the previous example, I'm just going to copy and paste this here, and we add to the end of the list here an unnamed argument, and I'll just put the string unknown. The value in y did not match exactly as we already saw, and so if I run this again, you'll see that now we get the string unknown returned instead of the value null. If you try to include multiple unlabeled options, you will actually get an error when you run the function.